Hello, welcome everybody. I'm Mark Turner, the External Relations Director of SRM 360, and welcome to our second live discussion. We're a relatively new nonprofit organization. We formally launched in May in South Africa, and our primary goal is to support and inform discussion about sunlight reflection methods, also known as solar geoengineering or SRM. This is a controversial topic. So, for our part, we don't take a position on whether SRM should be deployed or not, but we do support its research in the context of a heating world and broad-based discussions on the best way forward. And this is part of that. Our goal is to present the science and the issues in forms that people can use so that they and their audiences can come to their own views and contribute to decisions. So thank you again so much for coming. We've got quite a lot of people signed up already, 70 people in the audience and rising. So that's really exciting. As we go ahead, you can ask questions in the Q&A, and what we'll do is we'll have two different answering sessions, one about halfway through and one at the end, where I'll direct those questions to the various panelists. So I'll now turn over to Pete Irvin, our editorial director, to get things going.
Welcome. Well, it's only late July, but much of the world has already experienced exceptional heat this year. In late June, Western and Southern Europe endured an exceptionally intense heat wave. Daytime temperatures exceeded 40 degrees Celsius across Spain, Italy, and Greece, prompting Greece to ban outdoor work and close the Acropolis in Athens. In the US, two major heat waves in late June and late July each affected over 200 million Americans, with temperatures above 90 degrees Fahrenheit or 32 Celsius for days on end. And in Asia, a prolonged heat wave in late June and early July saw 10% of China's weather stations recording temperatures above 40 degrees Celsius over a 2-week period. The event led to China's first ever nationwide heat health alert, with record-breaking demand on the power grid and major public health concerns. While there are many uncertainties in climate change, it's clear that global temperatures will continue to rise for some decades, even with emissions cuts, and this will lead to more intense heat extremes. However, according to the United Nations Emissions Cap report, countries' current policies will not lead to a near-term reduction in global emissions. Instead, these emissions will plateau for the next decade or so. This could put the world on track for at least another 1 Celsius of global warming and an even greater increase in extreme heat in much of the world. This otherwise inevitable increase in extreme heat is the context for today's discussion, where we will focus on the impacts of extreme heat, what can be done to adapt to it, and the potential and limits of solar geoengineering as a response. With that, let me introduce our panel. Jeff Goodell is a journalist and author of 2 highly relevant books, the New York Times bestseller, The Heat Will Kill You First, published in 2023, and How to Cool the Planet, Geoengineering and the Audacious Quest to Fix the Earth's Climate, published back in 2010. Next, we have Dr. Jackie Kado, leads the network of African science academies based in Nairobi, Kenya, and works on bringing science into policy across the continent. We also have Trisha Patel, a research assistant at the African Climate and Development Initiative at the University of Cape Town, studying solar geoengineering and climate extremes. And finally, Tony Harding, an assistant professor at Georgia Tech who focuses on environmental economics, particularly on issues like solar geoengineering, which are at the intersection of novel technologies and climate policies. Jeff, let's start with you. Your recent book explores how rising heat is impacting people around the world. I'd like to start a conversation at the human level, focusing on what heat can mean for people's lives and livelihoods. Was there a particular story that drove home for you the health dangers that extreme heat poses?
Thanks, Peter, and thanks everyone for joining us for this conversation. So the answer to your question is very explicitly yes, and it was very personal story what happened. When I had written my book about geoengineering in 2010, I had not really thought about extreme heat as a kind of driver for a lot of this. I was thinking more on a sort of meta climate scale, thinking about glaciers in Antarctica and things like that. And my kind of understanding of heat had started at a very specific moment, which was in Phoenix, Arizona in the summer of 2017. I happened to be there for to do an interview for a completely different story. It was a very hot day. My Uber was late. I had about 10 blocks to go to get to a meeting, and I decided, what the hell, I'll run. And I went out into the street and hit a wall of heat and thought, oh, that's no big deal. I'm tough. I ran about 5 blocks, became dizzy. Um, my heart started pounding, and I thought, oh my gosh, this is dangerous. And what's remarkable about that moment for me was that I had been covering climate change for about 20 years at that point, and it kind of never really occurred to me that heat could kill you, and it could kill you quickly. That it was personally dangerous, and even for someone like me. And so I thought, if I don't understand this, a lot of other people probably don't either. And so that was where my book began. And I think that, and that was what, less than that was eight years ago or so. And I think that our understanding, ours meaning the scientific community and politically, understanding of the risks of extreme heat have changed dramatically over that a period of time. Not just because the temperatures are rising, but we're also understanding how deadly extreme heat can be. But we're also understanding how much we don't know about the dangers and risks of heat. And that, to me, is what makes this story right now continually interesting. We're seeing all kinds of other kinds of effects besides mortality. We still don't have, of course, good mortality numbers, but impacts on everything from suicide rates to mental health to economic productivity. The full scope of the impacts of extreme heat are still very poorly understood.
Yeah, and so I guess your example, you were working out, you were running on a hot day. This impacts people working as well. It can be quite dangerous. And you had I believe you had a story in your book that touched on how that can impact people's lives.
Well, in my book, I talk about the division between the cooled and the damned, and by that I mean people mostly like us, probably like everybody listening to our conversation today, who have access to air conditioning, who live more or less in a kind of climate controlled bubble. More or less, we have to run out to the store or to our cars on a hot day or whatever. But more or less, we are living in a comfortable climate zone wherever we are because we have the wealth and the means and the knowledge to make sure of that. But there's, a whole other segment of our world, um, who are people who are working outside, people who are do not have access to heat, to climate control, to air conditioning, to shade, to water, things like that. Um, and that is the big division in sort of risk factors for extreme heat, and that is a division that sort of is only growing. And in my book, for example, I read a whole chapter about an agricultural worker in Oregon who died during a heat wave. And he was, it's a classic story. He was a migrant worker. He came to Oregon to try to make some money to go back to Guatemala to build a house for his wife. He was from Guatemala. He thought he understood heat. It was a heat wave was coming in the Pacific Northwest in 2021. He knew about it. His mother even called him the night before and said, Sebastian, be careful tomorrow. And she was in Guatemala. I hear it's going to be hot in Oregon. Be careful. And, he was working in a field, and like a lot of people in vulnerable jobs, they think, rightfully in many cases, that if they complain or demand taking a break, they could be fired. They could lose their work. So they do a kind of arbitrage of like, okay, I'm tough enough. I can handle this. And poor Sebastian could not handle it. He was found dead in the field in the afternoon with a jug of water at his side. And to me, that was emblematic of the kind of people who are really at risk here, that this is not a kind of level playing field, that there are many, many hundreds of millions of people in the world who are vulnerable to this in ways that, we don't think about often enough, and that there are very little, even in the United States, much less the rest of the world, worker protection laws, things like that, to protect people from the risks and dangers of extreme heat.
Thanks. So, Tony, could you give us a sense of the scale of this threat? Like, how many people lose their lives to extreme heat each year?
Yeah, that's a great question. And I think at least for me, when I started learning about this topic, more than I would expect. I think you hear sort of the one-off numbers after a heat wave or something like that, but those numbers are typically just deaths that are predominantly reported as related to heat. But once you get into sort of the research on this and the statistical modeling, the numbers are actually end up being quite a bit larger. So there's a lot of work to sort of use data on historical temperatures and historical extreme heat, and then sort of build statistical models around this to try and understand, okay, what is the relationship between if I increase the temperature on a day by a couple of degrees Celsius, what does that statistically do to expected mortality rates in a given region in a given time? And so some of the more recent studies so this is not even just all heat-related mortality, but just the heat-related mortality that's attributable to changes in temperature to today are around 2.2 deaths per 100,000. And so to just put that in perspective, that's about 200,000 deaths. So currently each year there's excess mortality of about a couple 100,000 deaths each year due to heat. And that's really just the heat globally. Yeah.
And is that primarily people like Jeff was describing, working age people exerting themselves on a hot day, or is it more vulnerable members of society that are suffering?
Typically more vulnerable. So again, there's been a lot of work to try and tease out who ends up being most susceptible to this. Often it is people who have a lot of outdoor exposure. And so those are people who are working outdoor jobs or who just typically spend more time outdoors in the heat. There's also quite a bit of variation across age groups, right? So typically those who are particularly young, under the age of 5, or those who are older, over the age of, let's say, 65, tend to be quite a bit more susceptible than those who are in the middle age group. But income is also a very big driver of it, right? It's your ability to adapt, to build that sort of climate bubble around yourself, as Jeff was saying, to sort of insulate yourself from that extreme heat makes a very big difference as well.
Yeah, and so what impact does this have on the economy? Because I guess some of us work indoors, and I have the AC on right now. I'm rather unaffected by the weather, but if you've got to lay roads or build buildings, you've got to do it outside. So what impact does extreme heat have on the economy?
Exactly. It can be a pretty big drag on the economy. So current estimates suggest, bundled up all of climate change has losses anywhere from, let's say, 8 to 25% of GDP by the end of the century. And a good chunk of that is due to extreme heats, right? We know this has an effect on people. We know it has effects on our infrastructure systems, our bridges. We know this has an effect on agriculture and our food systems. So it's really impacting things up and down throughout the economy in a pretty big way. So I think it's helpful for me when thinking about these numbers to have it as a comparison. So if we think of let's say 8% loss in economic productivity by the end of the century, COVID, we saw a temporary loss of about 3 to 4%. Right, so it's essentially double the size the economic losses of during the COVID period, but it's not just for 1 or 2 years; it's year after year after year after year. So, yeah.
And I guess an area that I think, I don't know, you can tell me if it's been incorporated properly, but the educational impact. I mean, I can imagine trying to think straight on a hot day is hard. So trying to learn must be particularly difficult. Like, what impact does that have on educational outcomes?
For sure. Yeah, it has a pretty strong negative effect on cognition. So we know that it's a bit harder to be productive to learn on a given day. And the issue, particularly with learning is cumulative, right? It's not just, what am I learning today? It's what did I learn yesterday, and building on itself, building that stock of knowledge. And so when you have sort of consistent, repeated exposure to heat, that accumulates, right? And so that can have a very detrimental effect on student learning and student outcomes. Yeah.
Right, thanks, Tony. Jackie, what do these changes look like on the ground in Africa? What impacts are extreme heat having in urban and rural areas?
Thanks, Peter. For Africa, I think the impact both for global warming as well as extreme heat are no longer distant threats. I mean, it's not things you just hear in the news. They're actually here with us, and the impacts are actually escalating. And I think, as you heard from both Tony and Jeff, that in urban areas, it's different from how the rural areas are being impacted by this. So, for instance, in the urban areas, the extreme heat is intensifying the urban heat island effect, essentially saying that particularly growing cities where there are many informal settlements, there's a lot of lack of green spaces, adequate ventilation, or even access to cooling infrastructure. So, for instance, in Nairobi, where I live, or even Lagos or Accra, people in low-income neighborhoods are experiencing temperatures that are several degrees higher than the wealthier or better serviced parts of the same city. In the rural areas, the story is actually different but more urgent. Farmers, for instance, are now experiencing shorter planting seasons, reduced soil moisture, and even more frequent heat stress on both crops and livestock. So I can say that this directly threatens food security and livelihoods, because in most countries in Africa, the rural areas are the breadbasket for the country. And then even the heat waves that we're seeing in parts of the Sahel area, or even the southern African area, the Horn of Africa, we've also experienced increased wildfires. There's also a lot of water scarcity and ecosystem degradation as well, all of which literally just undermine how rural communities can cope with the heating effect of global warming.
Yeah. And so you mentioned there urban areas. I guess a big trend we see across Africa and other and across the developing world is a rapid urbanization. And as you're saying, it seems like urban areas are warming faster. You these dark surfaces that trap heat. How big a factor is that in raising the threat for African communities?
I think it's huge. And I think for us, what we're noticing is the disparity where you need intervention that would sort of clean the place up, because we have a lot of high-rise infrastructural development that trap heat. You know, you end up with a concrete jungle, so to speak. But that has effects, and I think mostly even health effects, has education, just as Tony was talking about. The impact is severe, but I think the awareness for this impact is not being well managed, and then there's no coordinated way of governing. Even, for instance, not having a hazard structural development, and then I think the zeal for infrastructural development separate from the impact that it has on the environment, on biodiversity, is also something we are seeing that really has to be dealt with. So the impact is huge and long-term, yet the short-term gains that you get from having infrastructural development is leading to a sense almost that is overlooking the climate impact of that development.
Okay, thanks, Jackie. Yeah, we're having a little bit of audio issues there with Jackie's sound, but hopefully that might clear up. But we'll try and sort that out in editing after the fact. But Trisha, how is global warming affecting heat waves? Just in a basic sense, what is the fact the world is warming doing to these extremes of heat?
Yeah. Hi, Pete. It's so lovely to be part of the conversation with you all today. And to answer your question, I think it's important that we sort of start by looking at the bigger picture, and beginning with greenhouse gas emissions. So these include carbon dioxide and methane and water vapor. And the amount of greenhouse gases that are in the atmosphere are increasing because of human activities like burning fossil fuels, deforestation, and industrial processes. And these gases ultimately, they trap more heat in the atmosphere. This is a process that we know as the greenhouse effect. And this is why we're seeing a steady rise in global temperatures. And the more heat that we have in the atmosphere, the greater the frequency of heat waves that we experience, and the intensity of those heat waves also becomes greater.
Great. And so, and there's a few other factors. I mean, it's not just the atmosphere is warmer. There's also a role that the land surface plays. I know, for example, in Europe, we had a very dry spring, and this sort of helped set up the extreme heat we saw. Is that correct?
Yeah. So the way that we experience heat is so varied across the world, and that's because it's not only about the air. There are so many factors that play into this, and aridification is one of these. And this is when land dries out over time, either from drought or longer-term climate shifts. We see less moisture in the soil to evaporate. And normally that evaporation acts almost like an air conditioner. But when soils are dry, more of the sun's energy goes directly into heating the ground and also the air above it. And that's why regions with dry soils often experience more severe and dangerous heat extremes, like the example you just gave. Yeah.
Yeah. And moisture also plays a role in our experience of heat, right? So what role does humidity, the moisture in the air, play in our sort of physical experiences of heat?
Yeah, so I mean, humidity directly impacts how we feel heat. And we often when we speak about humidity, we speak about the wet bulb temperature. And this is essentially a measure that combines both temperature and humidity in a location to tell us how well our bodies can cool themselves by sweating through perspiration. So at high humidity levels, sweat evaporates more slowly. And when the wet bulb temperature reaches around 35 degrees Celsius, the human body is no longer able to cool itself effectively, even if you are standing under the shade or underneath running fans, or even if you're in cool water. And at that point, prolonged exposure to this wet bulb temperature or beyond the threshold can become fatal to your health. Even for a regular healthy person with no predispositions. So these kinds of conditions are now being recorded in parts of South Asia and the Gulf region. And as climate change continues, they're also likely to become more frequent and widespread across the world.
Yeah, and I guess before it goes past the limits of human tolerance, that's sort of in the shade doing nothing. Activity, being in the sun, all of these factors sort of lower that threshold and increase your danger, right?
Yeah, it all takes us there eventually. I can speak into another factor that plays into how we feel heat, and I think it's aerosols, and these are tiny particles in the atmosphere that come from both natural and human sources. So some aerosols, like sulfates, they reflect sunlight, and they can have a cooling effect. And they're released through things like industrial activity, but also more everyday sources like exhaust streams from traffic. And right now, I can give you an example. China is currently they have been for a while, they've been working to reduce aerosol pollution through the Clean Air Action Plan, which is a public health and environmental effort aimed at improving air quality. And it's really important for people's respiratory health and for the environment more broadly. But at the same time, fewer reflective aerosols in the atmosphere might mean that we temporarily lose some of their cooling influence, which could result in sharper spikes in near-term warming, especially in already heat-vulnerable regions. And I think this contrast just helps us in highlighting something very important, which is that different types of human-caused atmospheric changes, greenhouse gases versus aerosols, they can have very different and sometimes conflicting effects on heat and how we feel it.
Yeah, I believe India is actually one of the patches of the world that hasn't warmed as much or nearly at all compared to the rest of the world, partly because there's a large aerosol cloud at some of the time. Right, well, we're going to have a short intermission now for questions. So I'm hoping some have already come in, but if you've got any,
Yeah.
type them in quickly and Mark will serve them up.
Absolutely, and we'll probably focus in this half on the heat impact related questions rather than some of the SRM related questions, as we're going to get to that stuff in the second half. Just picking up on the point, and I think a lot of Sumitra Das's questions has already been answered by you, Trisha, but do you have a sense, or anyone else, of course, for that matter, what are the projections for areas in South Asia that may exceed 35 C by 2050? This is in the line of kind of talking about wet bulb temperatures. And do you have a sense of estimated migration patterns or population displacement forecasts due to extreme heat by that time?
That's a really great couple of questions. I personally don't have like statistics on hand, but I can speak into that. The average temperatures in for example India right now are actually quite crazy, and I have a friend who is from India, and the other day he told me that 42 degrees Celsius is a very comfortable temperature for him to experience in one day, which I just thought was absolutely crazy. And it's just getting hotter. And so I'm not entirely sure how migration patterns in the area, the region are mapped out at the moment. Maybe one of the other panelists might, but I'm not able to speak into that right now.
We hope to have Tom Matthews on the panel. He couldn't make it, but he was specifically focusing, or he's doing some work specifically on this question of how close are we to these impossible to survive heat conditions, and it's some ways off. It seems like we think we need to warm quite substantially to really see large areas affected by it. But there will be short-term blips where those temperatures occur, and they'll become more frequent as the world's temperature rises.
Tony, I saw that you were reacting to that one. Did you have something to add on migration patterns?
I wish I had the statistics on hand. I just know there's a lot of work on climate migration and trying to understand that. I don't know like specifically the expected numbers, but it's very interesting coming from that. The one thing I can say is my understanding from that literature is that there's actually a lot of internal migration before there's external migration. So a lot of people moving around within the country before they ever move out of the country. But when you have this sort of similar patterns of warming around a smaller region like that, then you really have nowhere else to go in some ways. So it's just interesting to think about. Yeah.
I wanted to direct you to actually one other question. We had a question of how, in terms of heat deaths, compare with extreme cold deaths. Is there something you would like to say on that?
Yeah. Again, I wish I had looked up ahead of time the current relationship between cold and heat, but for sure there's evidence of a reduction in cold-related mortality, right? So we know that typically we see sort of increases in statistical mortality rates when it gets very hot, but we also see a similar relationship when it gets very cold, right? And how those relationships sort of balance depend a lot on the region. So typically hotter regions that are exposed to more heat tend to have more heat-related deaths. And also as temperatures increase, because there's this sort of nonlinearity, this U shape, as those already hot regions get even hotter, they're particularly susceptible to that heat-related mortality. Same thing on the other side. So if we have these colder regions of the world, they tend to experience more cold-related mortality. So as temperatures increase, we actually do see a reduction in that cold attributable mortality. What I can say is sort of on net, looking forward, out to 2100 for sort of a moderate warming scenario, we would expect somewhere in the ballpark of 1 million extra deaths per year. And that's sort of on balance between the change in the heat-related mortality and the reduction in cold-related mortality. So while the the cold deaths are going down, but the hot deaths are going up even faster than the cold deaths are going down. Yeah.
There's another question here with regards to air conditioners from Cynthia Scharf. I'll read out the full question and then ask maybe Jackie and Jeff to address the issue of air conditioners. Cynthia's question is, does what was agreed in the Kigali Amendment to the Montreal Protocol address the use of HFCs in air conditioning, including in the type of air conditioners sold in India and elsewhere in the global south? In other words, if more air conditioners are sold in India and the global south, are we dramatically increasing the risks for climate change? Jackie, do you have any thoughts on the issues of air conditioning?
Okay, yeah, thanks. I think it depends, because what we've seen is that even when you have those political statements with conventions that go with how governments or countries will manage global warming as a whole of climate change in particular, what happens is the policy document looks right, it reads very well, and it's very practicable. But the implementation bit usually lacks is how to enforce what's been agreed upon. Now, I think the person asking the question is comparing air conditioning issue, how it's being used in Africa compared to India. I think I haven't done the study on that, so I wouldn't have a direct answer, and whether air conditioning is impacting that more. I think the safe answer would be it depends, because if you're in Nigeria and there's a lot of use of air conditioning, I think the response would be different from if you're in Nairobi, where there's less use of air conditioning, because people even don't use mostly air conditioning for domestic cooling. So it depends, and therefore I'll not be able to give you a straight answer.
Okay, well, thank you very much. I think we're going to move on to the second half now of this discussion, and we can have a lot more time to address some of these questions later. So please go ahead, Pete.
Oh, back to you, Jackie. What kinds of adaptation efforts can developing countries take to cope with the rising threat of extreme heat? Sounds like air conditioning is available in some places, but not all. What can they do?
Yeah, so that's actually a good question. So I think in Africa and global countries in general, there has to be a consideration of three fronts. It has to be a three-pronged approach. So we need to take nature-based measures, infrastructure-based measures, and social adaptation measures, just to give it a go, to be able to respond to extreme heat. Let me just briefly describe those three measures independently. So nature-based solutions or measures, in this case, would be things like expanding urban green spaces, restoring wetlands, and even planting trees in and around settlements, which can significantly reduce ambient temperatures, but it's also low cost, sustainable, and it provides core benefits, including cleaner air, even better mental health. We're talking about earlier how your mental health is also affected by how much heat your body can take or withstand. The kind of second approach would be the infrastructure investment. That it has to be critical and holistic. This includes developing heat-resilient housing, especially in informal settlements, using materials that reflect rather than absorb heat, because in most settlements they use iron shields, which are not very good regulators of temperature. But then also to build cooling centers in community hubs such as schools, health clinics, or even offer temporary relief, especially during heat waves. Some countries are also experimenting with reflective roofing for shaded public spaces or improved ventilation in public spaces like schools or clinics. And lastly, which is the third approach or measure that we should use, is social adaptation. This is important because it ensures that the public is educated about hydration, about working on adjustments, especially for outdoor workers or laborers, And especially in Africa, where you have a lot of motorbikes, we call them in Nairobi border borders, to regulate what times that they spend outdoors, or even have some shade built, custom-made motorbikes that have shade on them. Heat help early morning systems.
Sorry, Jackie, we really can't hear you, I'm afraid. I think I'm just going to have to move on. Hopefully your audio clears up a little later. But so, Trisha, could you briefly explain what stratospheric aerosol injection is and how it could affect the climate?
Yeah, gladly. So SAI it's one proposed technique within a broader category of ideas known as solar radiation modification, or SRM. And the basic idea behind SRM is to slightly increase the amount of sunlight that is reflected back into space. So in other words, to enhance Earth's natural albedo effect. And SAI specifically is inspired by what happens after large volcanic eruptions. And an example is when Mount Pinatubo erupted in 1991 in the Philippines. It released lots and lots of sulfate particles high into the atmosphere, into the stratosphere, which is the second layer of the atmosphere from the ground. And this had a measurable cooling effect on the entire planet for a year or two after that. And that's led scientists to ask, what if we could recreate this effect in a controlled way? And so the idea behind SAI essentially is to release tiny reflective particles, usually sulfate aerosols, into the stratosphere, so about 20 kilometers above the Earth's surface, where they would form a layer that reflects a small fraction of incoming sunlight before it reaches the surface. And in theory, this could reduce global temperatures. So most of what we know about SAI at the moment comes from climate model simulations. And across many studies, there is general agreement that if deployed, SAI could lead to an overall cooling impact across the planet. And this cooling could also help reduce the intensity and the frequency of extreme heat events, especially in regions that are already heat stressed. And this is because even just lowering the amount of solar energy that reaches the surface, even by a small amount, can help break the feedback loops that drive dangerous heat extremes. For instance, less incoming heat can reduce surface temperatures. It could limit how quickly land heats up, and also reduce the chances of reaching critical heat thresholds. So in a nutshell, that's how it could affect heat.
Yeah. And how effective is it? So, if we were, the world's, let's say, on track for another 1 Celsius of warming, if we were to offset that 1 Celsius of global warming, would we expect extreme heat to stay as it is? Or, would it be partially effective? Like, how well would it work at reducing extremes of heat?
Well, I'd say based on studies, it would be incredibly effective at reducing extreme heats, as well as average temperatures too. So when it comes to impacting heat, there's like consensus that it would effectively reduce extreme heats. And so the cooling effect is what's most commonly agreed on across the studies. That's for temperature as a variable.
Yeah, and this is, I guess, just to make clear, this is a global phenomenon. You can't create like a patch hovering over the UK. This is something that would be a global aerosol layer.
Yes, SAI is researched as a global climate intervention technique, compared to like other SRM techniques like marine cloud brightening, for example, which are a regional scales sort of research technique. So
yeah. So it works well for temperature and some of the temperature-related variables, but it also changes rainfall patterns, right? So what can you say there about roughly what happens to rainfall and how worried we should be about that?
My answer is definitely not as straightforward as for temperature. All of the studies show that SAI's effects on rainfall are projected. They're quite complex. So the Earth's hydrological cycle, which captures how water moves through the atmosphere and across the land, is shaped by many interlinked processes. And while cooling the planet tends to reduce overall evaporation, studies suggest that SAI could lead to drying in some regions, to intensification of rainfall extremes in others, and to changes in seasonal patterns. So it's not simple or uniform when it comes to rainfall. And an example maybe that I could speak into quickly is the Intertropical Convergence Zone, or the ITCZ. So this is a band of clouds and storms that circles the equator, and it tends to shift towards the hemisphere that's warmer. And if SAI were deployed in the northern hemisphere more strongly, for example, or only in the northern hemisphere, then that part of the world might cool faster, potentially pushing the convergence zone further southwards. And this could disrupt rainfall in places that rely on seasonal climate systems like the West African summer monsoon, with consequences for agriculture and water access.
Yeah, so there's definitely some bad ways to deploy this, and doing it only in one hemisphere is not recommended.
Risky.
Yeah. Cool. So Tony, we talked a little bit there about the climate effects, and you had a paper recently in PNAS that looked at extreme heat, but and the heat impacts of SAI, and compared that against its sort of non-climate side effects on ozone and on air pollution.
Mm-hmm.
How did those risks weigh up, and how did you approach that problem?
Yeah, so we were particularly interested in sort of the human health related impacts of SAI because we know that human health impacts is one of the biggest drivers of costs of climate change. And so we thought it was important to understand how SAI would affect, in particular, temperature attributable mortality. So that is a fancy way of saying deaths related to hot temperatures and cold temperatures. And so what we did is we took one of the sort of state-of-the-art models of temperature attributable mortality that's based on statistical modeling using historical data on the relationships between temperatures and excess mortality. And then use that to compare a world with solar geoengineering versus a warming world without solar geoengineering, right? So we wanted a clear counterfactual of what happens to temperature attributable mortality over time if we were to deploy solar geoengineering. And we find solar geoengineering does a pretty good job at offsetting the increases in temperature attributable mortality on net globally, right? But the pattern is a bit more diverse at a regional scale. Again, a bit due to those differences in regions in terms of which ones predominantly have cold attributable mortality and those that predominantly have heat attributable mortality. So typically in more northern parts of the world, the sort of increase in cold temperatures increases mortality there versus in sort of the hotter, more southern parts of the world, the cooling effect actually dominates and reduces temperature attributable mortality. So on net, the reduction in heat related mortality actually ends up outweighing the increase in cold related mortality. But in that paper, we then sort of took one step further. We wanted to understand, okay, another big concern of solar geoengineering is the direct side effect risks, right? And two of those are the direct risks of the aerosols themselves, right? If we put, for example, sulfate aerosols into our stratosphere, that's going to, one, come back down, but two, do things also to the stratosphere that affect changes in ozone and UVB exposure. So we wanted to understand what is the relationship between those direct mortality rates and the change in temperature attributable mortality rates. And we find that the benefit from the cooling in terms of the heat and cold related mortality on net outweighs the increase in mortality from the direct aerosol risk by a factor of about 10. Right? It changes a little bit and there's some uncertainties in there, but at a global level, the sort of benefit from reducing temperature attributable mortality outweighs the direct mortality risk by about a factor of 10, right? But again, I just want to caveat that this is just a couple of the potential impacts of solar geoengineering, specifically the temperature attributable mortality risk and the air pollution UVB exposure risks. So there's definitely other risks to include if you wanted a more comprehensive analysis.
But I guess this was, in my mind, this was quite a big paper because those two side effects, the ozone impact and the air pollution impact, I think loomed quite large in our imagination of the overall risks of SAI. And to find that despite, well, uncertainties paused for 1 minute, that the impact just on heat alone, not on the other effects of climate change, just on heat alone outweighed those two big side effects of SAI by 10 to 1 is, I think, quite an important finding. Just moving on now, Jeff, you published your book, How to Cool the Planet, back in 2010. And in the 15 years since, fossil fuel CO2 emissions have risen by maybe another 15% or so. So solar geoengineering was just being discussed when you published your book. What's your sense of how that discussion has evolved and how the broader community is reacting to it?
Oh, good question. I would say that the science has gotten much better and the politics have gotten much worse. I think that back when I was first writing about solar geoengineering 15 years ago, so a lot of the scientific questions that you and Tony and lots of Trisha and other people have done a lot to clarify and to do better modeling. We have a better understanding of the potential impacts. But back then, in the real world, we had trust in institutions. We had people who were running our governments who believed in science and this sort of rational, scientific-led understanding of a complex and potentially dangerous and potentially beneficial technology like this seemed part of the conversation in a way. And it seemed like I wrote the book because I think it's an incredibly valuable and dangerous tool. One of the only tools we have to really cool things off quickly. And so I wanted to explore the implications of that. But I mean, when you look at where things are today, right? I mean, in the United States, we have, people like Marjorie Taylor Greene, the MAGA conservative congresswoman from Georgia who's, whenever there's a hurricane, she's talking about geoengineering causing the hurricanes. And you have this whole conspiratorial rise in American politics but it's not just America. More broadly, this corruption and corrosion of faith in institutions. And I think without that kind of trust, a technology like solar geoengineering is very difficult to imagine being deployed in a way that is not just become this sort of atmospheric accelerant for conspiracy theories. And that is what kind of worries me the most right now. And just one other point that I would like to make is there's an interesting comparison with AI, right, which is another very dangerous technology, another technology that sort of emerged out of nowhere, and it's taken off, obviously, in all kinds of ways. But the reason is because there's a lot of money to be made by entrepreneurs and others. One of the things about solar geoengineering is no one's figured out any way to make money off of it, right? What might have been a kind of accelerant for better or for worse in understanding and even possibly, advancing the science even farther. But there still is not a sort of profit engine. And one of the last thing I'll say is one of my concerns is that it gets taken up by, the sort of Silicon Valley crowd, that Elon starts touting it, or Peter Thiel or something like that, as a kind of fix for allowing the fossil fuel industry to keep burning and to keep going. So I think the landscape has changed a lot.
Jeff, maybe I'll bring in one of the questions from the audience here from Yvette Ramos. It's about the UN and the likelihood of UN governance. The question is, well, first, will the next UN Environment Assembly, what will it decide about SRM? But do you think that some framework convention agreement could be discussed at the UN level? What is your sense on the hopes for international governance for this, or the prospects?
Well, I mean, we've seen incremental progress on this in UN discussions, and I do think that the sort of kind of looming reality of solar geoengineering, I think, is driving some of this discussion. But I think the broader question is, what does international governance mean in our world now? I mean, the US, of course, is leading the charge, but I think that we're in an era where, I mean, a lot of climate scientists that I talk to think that these international agreements are going nowhere and that the whole structure needs to be reimagined. And I think we're at a kind of crucial turning point in all of this in ways beyond just solar geoengineering. And I think that, this question of governance has only gotten more complicated as these international norms have eroded.
I've got a few questions here from Jeff around the question of one technique we haven't talked about here today, surface albedo enhancement, essentially more reflectivity from the ground, and to what degree also the global south countries could be involved in doing that. Trisha, do you have any thoughts on what the sort of relative prospects are for that set of approach?
Yeah, sure. I think that surface albedo enhancement techniques they've already been taking place and happening, and I think that they've been happening at a lot, like small scale community-based initiatives actually make some effort to increase reflectivity within their communities. And
what might be some examples of those? What would that look like?
Most commonly painting roofs white and researching crops that are more reflective, but also that are also compatible with an area's natural climate system as well as its ecosystem. So planting crops that are, yes, more reflective, but at the same time beneficial to a local ecosystem. These are smaller scale reflective efforts, and I think they are being done. And I think they're lovely. I think they're lovely, actually. I think community-based efforts go a long way in fostering community and strength, and just help in creating a picture and a unified goal that people work towards. So I actually think they have a lot of value in that way.
And could a lot of those interventions in a lot of different places add up to a large climate level effect, or is this still fundamentally a local effect we're talking about?
To my knowledge, the effect is it doesn't generally, it's not calculated to add up to have like a global sort of effect. Yeah. So that's why I think the value is more in what it could do for fostering a sense of community.
Tony, I have a question here from Tristan Spot. Do heat waves respond differently to cooling from SRM than to an equivalent cooling achieved by reducing atmospheric CO2?
That's a good question. I don't know that. I think there may be other people on the panel who might be better suited to answer it, but I do know that typically I think it's through the changes in the hydrological cycle, there is a particular dampening of extremes and variability from SRM relative to an equivalent CO2 reduction. So you get sort of a small reduction in the amount of time spent at extreme heats and extreme colds. But a climate scientist might have a better reasoning for why that is, but that's what I know. Yeah.
I might jump in briefly. I mean, I think the fact is, if you're dimming the amount of sunlight coming in, sunlight acts most strongly in the summer and in places that are sunny, and CO2 and greenhouse gases heat all the time, but they particularly heat in the winter at night in those kind of colder places. So we sort of see roughly they sort of, you offset roughly on average 100% temperature, because that's what you're doing, but maybe a little bit more, 10% more in the summer and in the hot places, and maybe 10% less in the cold places and the cold times. It's sort of roughly the order, but it works pretty well across the board on temperature.
Yeah, if I can chime in, just in the experiment we did, we did sort of an idealized experiment of global SAI, and what you get out of that is a bit of overcooling in a way of the equatorial regions that are particularly susceptible to the extreme heat. So you get sort of an added benefit in those regions of a bit more cooling in the places that are particularly susceptible to the heat. So
we have a question here from Fiona regarding how long SRM might need to be deployed for. The question is, I read a paper by Susanna Bauer from 2023 suggesting that once deployed, SRM would need to be sustained for approximately 150 to 400 years to achieve its goals, thereby binding future generations. I would welcome your views on the potential duration of deployment. Trisha, do you have any response to that?
Yes, I think that's a really important consideration, a very practical one. And I think that the length of a deployment program could also be quite largely influenced by the deployment scenario and the sorts of climate goals that you're working towards achieving with your program. So I think that if you wanted a more moderate deployment program, I think you could do it for a longer period of time. But for example, if you were very ambitious and you wanted to achieve a very a great degree of cooling within a short amount of time, one could think that you just need to inject more aerosols to achieve this effect. But then it's not quite so simple, because if you inject too many aerosols, they begin to group together and they become heavy and then they settle. So it's counterproductive. So in terms of the length, I think that could very largely be influenced by the climate goal that you're working towards when building your deployment scenario.
If I might jump in again, one of our colleagues at SRM 360, Linus Baselius, did his master's project on precisely this question, actually. And he found in that study that you would overshoot temperatures, say 1.5 Celsius for the kind of periods that Suzanne Bauer was mentioning in her paper. But if you added SRM to keep temperatures cooler, you could shorten the duration of overshoot by some 10, 20%, by decades, because you're reducing the amount of heat that gets up in the ocean. And so the ocean being cooler makes it easier for temperatures to drop in that long run. And so, yes, you're committed for a long time, but you're committed for less time than you would be, presuming no changes in emissions, if you added SRM than if you did not add SRM to the scenario.
Jeff, do you have anything to add on thoughts of this issue of long-term deployment and those risks?
Well, on one level, there are scientific questions that I think, Peter and Trisha did a good job of articulating. I think the political aspect of it, though, is also, really important when you think about doing this for a long period of time, and you think about maintaining the sort of infrastructure and political will to keep doing this. That raises, real serious questions about what that would look like. I mean, we can't even maintain in the US, we can't even maintain aid to, the most desperate and vulnerable people in the world right now, right? And so the idea that we're going to build an infrastructure of something that needs to be continually replenished in real time every year, essentially, that's a real political problem. And that's something that I don't know how one grapples with, and what the sort of resolution to that is. But it is something that, really needs to be part of this conversation, because this is not a fix it and forget it kind of a technology. And in that sense, it's even different than air capture, right? Which does, remove CO2 from the atmosphere. And once it's removed, I mean, there's questions about storage and things like that, but it's not a technology that necessarily requires continuing kind of momentum and political support to function.
Thank you. And bearing in mind we're at the hour now, we're going to continue with this conversation for the next 10 or so minutes, as we've still got a few more questions here. But in case anybody has to leave now, thank you so much for coming. We really appreciate it. And please feel free to get in touch with us at SRM 360 with any further questions. And yeah, we're here to listen to you and to we'd love to hear about your thoughts. So thank you so much. And also thank you so much to all the panelists for coming. I don't know if any of you has to leap off right now, but otherwise we will just continue this conversation for another 10 minutes or so. Maybe I'll just bring in another question with regards to the concerns around weaponization. And maybe I'll just ask Jackie, first of all, on these sort of kind of bigger political questions, length of deployment, what that would mean politically, concerns about or fears about weaponization. Can you give me a sense from your side how important these are in thinking about SRM and its potential for or not for addressing heat?
Thank you. I hope my sound is better now. I think the thinking of SRM from the Africa side and from the academics that we deal with is still on the research side. So the level of weaponization, that discussion, we haven't had it yet, because if the reality of SRM is not tried, tested, and even researched within the research framework of the continent itself, then everything else becomes hypothetical. So even the attention that is required in terms of policy making, in terms of even generating curriculum for higher education is still something that most researchers are grappling with. So that would be a secondary level of questioning before the practicability of what does the research mean for the continent itself.
You're muted, Mark.
Apologies. I had another question with regards to back to aerosols. Maybe Trisha, you could help answer this one. This is from Jerry Jose. In terms of sulfur masking temperature and China seeing an increase in temperature, is this expected to be temporary, or is this something that will be reduced over time?
I assume this is in reference to the example I spoke about earlier with China's clean air project that
Please
they've been
go
working
ahead.
on.
Yeah.
The warming that would follow reduced aerosols is not, to my knowledge or understanding, long term, but it is near term warming. So I think it's a matter of the warming might happen and the climate might, if everything is all right, work to balance it out organically, following the decrease in the aerosols or the decrease in reflectivity. And I guess this is something that we research in the SRM field. It's called termination shock, and this is the idea that if SAI were to be deployed and then abruptly halted, then abrupt warming would follow, and it would be quite dangerous at a dangerous scale for life on Earth, because it would happen at such a fast pace that many species would not have enough time to adapt. And so we refer to it as I said, termination shock. And within the field, we've identified or recognized that if an SRM deployment scenario ever did happen, then it would need to be gradually phased out so that returning back to a normal climate without SAI deployment would look far more normal and not be harmful in an extreme way like that.
Brilliant. Well, thank you. I've realized we can't get to all the questions here today. Maybe I'll just ask one more question to each party. Something that has been very celebrated recently over the past week or so is the recent International Court of Justice Climate Advisory Opinion issued 23rd July 2025. And there's a lot of thoughts, hopes around there about how it might affect accelerated global action. Is this something that gives you hope? And how might that affect what we're thinking about? Well, how might that affect the atmosphere around discussing SRM? And does that change the equation at all? So perhaps I'd start with Tony on that one.
I'm not sure. Being honest, I don't know a ton about it yet. I haven't read too much about it, so perhaps maybe someone else. Sorry.
Jeff, go ahead.
Yeah, so I followed that pretty closely because of a new book that I'm working on that figures largely in, and I think it's really incredible and hopeful on certain levels, right? I mean, we have the highest UN court, making very clear the laws about what their kind of legal responsibilities are about climate change, about damages. I think it's going to be a big help in sort of breaking the logjam on loss and damage. It may influence litigation around the world about kind of responsibility for climate damages. I think it will inspire a lot of kind of lawsuits and a lot of, I think it will recalibrate international discussions on many levels, particularly, at the upcoming COP. But when it comes to geoengineering, I don't know what the impact will actually be, because I think that, I think broadly with these kinds of agreements, the lawyers that I've been talking to in the last week are like, this is great. This is really important. But, does international law mean anything? Does anybody going to really pay attention to this? I mean, what's the penalty for like not following these rulings? I think the evidence is really out on that. And I think that goes to the heart of what I was saying about SRM, is that, like, we can have all the international agreements we want, but who's going to pay attention to them? Who's going to enforce them? What kind of trust is there going to be in them? So I think it's much more complex and deeper problem than just a single decision by a court, even if it's one as important as the ICJ.
Jackie, do you have any final thoughts on that issue, how that might change the way people are thinking about?
Yeah, I think I'm with Jeff that policing such a ruling is difficult. It's not easy because it's something that affects everyone. But who would be the enforcer? I mean, as much as the jurisdiction of the international justice ruling is concerned, it's a bit superfluous of us to think that the people at the ground, the communities that would directly be affected by it would actually take heed or have a say, or even have a justice framework that would enforce that type of ruling. And I think if just to close on my thought on that is the same way geopolitics plays a critical role in how perception on what those rulings look like. And there are instances where even when it's a big issue at the local level, it can just be dismissed as their problem, and it's always somebody out there and not directly us. So I think it's going to be challenged to see the impact of that ruling at the local level. It's not easy to extrapolate the impact of it.
Well, thank you so much. We really are reaching the end now, so I'd just like to say thank you so much again. Please go onto our website for any further questions. I saw there was some around research funding, and we have, of course, our funding tracker online and our experiment tracker, so please check out some of our stuff. Pete, I'll hand over to you to close this.
Yeah, so as part of this, we've just produced what we're calling a risk primer. So there's a new risk primer on extreme heat and solar geoengineering that you can find on our website at srm360.org/primers. But yeah, thanks to all our speakers, Tony, Jackie, Jeff, and Trisha, for joining us. Apologies, Jackie, for the audio issues, but great to have you anyway. And yes, thanks everyone for attending. There's a survey, I believe, that I think might be in the chat. Kerry is nodding. If you have a chance, just do fill that out and let us know what we can do better and how it went. Thanks everyone for joining.
Bye. Thank you, everyone.
Thanks. Bye.